let's solve this problem in which you are asked to calculate the double integral of the function x plus y on a rectangular area given by x in the interval 0, 2 and y in the interval 1, 2. Okay, so first let's why not plot the interval. So x is going between 0 and 2, while y is going between 1 and 2. So our rectangle looks something like this. So that's our rectangle of integration, but of course remember that in 3D now the third axis out of the page would be the function, which would be a three-dimensional surface, so we are calculating the volume under that function. Okay, so let's do it. Our integral is the double integral in the area A of x plus y dA. But we are going to apply Fubini's theorem to write this as an iterated integral. So we write an integral inside of another integral. So what do you want to integrate first, x or y? So in the previous example I did x, so now I'm going to do y. So dy, and then on the outside is dx. So now I need to write the limits. So the integral on y goes from 1 to 2. So now the limits on this integral must be 1 and 2. Okay, this was, remember, an arbitrary choice. I could have written dx here and dy here, but then the limits would have to be different. So if I write dx here, I would have to put here the limits for x, which are 0 and 2. Okay, but since I wrote dx outside, the limits have to be written on the integral outside. Okay, so now I calculate the integral inside. So I need to find an antiderivative of x plus y with respect to y, and that's fairly easy. So let me write it here. This is the integral from 1 to 2 of x plus y dy. So this is equal to xy plus 1/2 y squared, evaluated between y equals 1 and y equals 2. Okay, which gives me 2x plus 1/2 times 4, that's 2, then minus x and minus 1/2. So this is equal to x plus 3/2. Okay, so that's the integral along y. So now I substitute that into the outer integral. So it's the integral of x from 0 to 2 of this function x plus 3/2 with respect to x, which I can do now. So I find the antiderivative of this function by using the fundamental theorem of calculus. I know that I need to find a function that whose derivative is this, so it's 1/2 x squared plus 3/2 times x, whose derivative is indeed what I wanted, evaluated between x equals 0 and x equals 2. So I have to substitute those. So this gives me 1/2 times 2 squared, that's 1/2 times 4, which is 2, plus 3/2 times 2, which is 3. So the final answer is 5. Okay, so the volume under the surface x plus y in this rectangular area here will be equal to 5. Okay, excellent. Again, I encourage you to try the opposite order. So change the x by dy and also change the limits so that they match with the corresponding variable, and check that the result is the same. How do you know which order to choose in practice? It depends. So sometimes it's easier one way or the other, and this comes from eventually practice and intuition. Most of the time it doesn't matter. So see you in the next video.